Okay, so here's the Punnett square completely filled out, and now we can go through each of the different genotypes that results from the fusion of these gametes and determine their probabilities and also their phenotypes. You'll notice that anything in this column or this column has at least one big Y and one big P because they're getting that from one of the gametes. So this indicates that these individuals will all have the yellow and purple phenotypes. Now there are other yellow-purple phenotypes as well. Here's one that's here, and here's one that's here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our 9/16. There are also individuals that have one recessive characteristic and the other as the dominant. So here's an example. Here's a plant that has yellow seeds and white flowers. Now there should be 3 of these. So here's one, here's another, and where's the third? Oh yeah, up here. Took me a second there, didn't it? Okay, so there's those 3. There will also be 3 that have green seeds with purple flowers. You can find those as well. And then there's only 1 that has both recessives. Now you can work your way through one of these Punnett squares, and I recommend it. It's worth doing at least once or twice so that you understand how it's done. On the other hand, there's an easy way to do a shorthand here. And that's simply to understand that a dihybrid self with 2 unlinked loci will always produce a 9:3 to 3:1 ratio that takes the following form. Now, we can use Y's and P's here, or you could use the generic A's and B's. There will always be 9 that have the dominance at both loci. Then one of the 3 categories will have their homozygous recessive at the one locus and at least a dominant at the other. The other 3 is the reverse, has at least one dominant at the one locus and homozygous recessive at the other locus. And then the one category is the homozygous recessive for both. So that's a very simple summary that always applies to a dihybrid self. Now, one thing that you've heard me say in the course a number of times is always to use the qualitative data before the quantitative data. This is one exception that I will make to that general principle. This pattern, a 9:3 to 3:1 ratio with this particular distribution of phenotypes, is diagnostic for an F1 dihybrid self, or an F1 dihybrid times dihybrid. It instantly tells you a number of things. It tells you that there are 2 loci involved, and that those loci are assorting independently of one another. As you'll learn later, this means that they're not linked to each other. They're assorting independently. They're not physically linked together close by on the same chromosome. So if you see a 9:3 to 3:1 ratio, you can instantly conclude that there are 2 loci involved, that they are assorting independently, and that is what's producing this particular pattern.